before try of making this, I will be explaining this this class I made. First, take it in the init method. You can take in any number of arguments, and it has to be a list of integers or just integers. If it's a list of integers, then it's going to run this one, because unpacking stuff like that. If it's just integers, then run this one, just run to a list. This self.even, it uses a method in this class to tell you if it's even or odd by true or false, stuff like that. This self.prime uses this module to get a list of a prime starting from 0 to the largest number in the argument that you put there. These are the methods, this one and this one, and this is also a method that's used in this method called get LCM. I didn't want to use the math LCM function, so I want to make one myself. That's why I'm making this video, because it took me quite a while to make it, because I didn't write down my process of making the function, making the class and stuff. So it gets the LCM by making a copy of the list of numbers, and then the prime factors is just empty. It's based on how many. I'm trying to make it scalable, so I use this a bunch of time in this function. It's based on how many how many elements are in this list. And
LCM is used later in here to calculate the LCM of the numbers and stuff. And this one just finds the primary factorization, because that was the fastest way I could find the LCM. I use prime factorization to find it. It goes through the amounts here, finds the prime factorization of each one by using this while loop. I got this idea from someone, a friend, I guess. Basically this while loop just says that until that number, it finds all the prime factorizations of it, then it will keep repeating it over here. If the number index module is divisible by that prime and it's equal to 0, then it's going to append its prime factorizations as a prime factor of that number. I'm not explaining very well, honestly. Suck at explaining. This part right here, yeah, it's used to find to basically make so that, because the prime factors repeat, it just turns it into a set and combines all the prime factors from each number in that list. So that's all this does. And this one just so much work. I can make this so much easier for loops. This one just says if the prime factor in like index 1 is also as index 2, it return true and false if it isn't. The factor number, that one, what did I use that one for again? Kind of forgotten. We're trying to remember. Loop through factor condition if the factor is true or false. Oh yeah, uses this to see if it's a factor of both those. It'll be index or element. Both those indexes. If it is, then it'll add it. It'll uses the where is it, size? Oh no, it was this one. It just uses the counts to find how many of those prime factors there are. It uses factors or power of this, how many factors there are, and LCM times. That's the thing that actually gets the LCM. It repeats this with every unique prime factor. That's what this does, and that's basically it for the return, the get LCM function.
I'm not gonna edit this. So much freaking talking. This test case, I use it to just see like if it really works. It works, and this print is always, I guess, you understand it. And test case 2 is random. I'm gonna run it now. Well, just find range that print stuff you should know. If you get it, I guess. And to show that works, the output is this. I'm gonna show my thought process because when I was making myself, I was just writing it along and not actually jotting down like how it should actually work. So it took me quite a long time to make this. It shouldn't have. These are correct. 43, yes. Yes, that's correct. This is correct. There's probably like stuff like this where it's easy to just do because they're the same number. Obviously, that would be the prime factor, and stuff like 1, the largest number would be prime factor. But I didn't do that. I just used prime factorization, which just made it longer. I'm not sure about the time complexity, but it's probably, I hope not O of n squared, but it's probably something like that. Because this, or is it? This takes a while. And well, that'll be it. I'm just gonna post this online or something. Great explaining. That was horrible, but great code. Maybe no.